Hi, I am Professor D.K. Panda from the Ohio State University. Together with my colleague Dr. Hari Subramani, we'll be having an exciting tutorial at the Supercomputing 2022 conference. It is titled Introduction to Networking Technologies for High Performance Computing. As many of you know, we are in a very exciting phase in the high performance computing. We have the Frontier system, which just got announced in June, and it has crossed one exascale, exaflop performance. And gradually in the next few years, we'll be seeing many more such systems coming up. And of course, prior to this, we have seen Fugaku, Summit, Sierra, Sunways, Twilight heading into that direction. Now, if you take a closer look at it, you will see the supercomputing systems are scaling very rapidly. And especially these are being designed with multi-core, many-core systems, high-performance interconnects like InfiniBand, Omni-Path, Slingshot, high-speed Ethernet, Tofu, NVLink, and also EFA, etc. Now, in that context, if you take a look at the computing cluster, where you try to put together a lot of servers and then combine them into define with a high performance interconnect network, and that is your high performance computing cluster. But similar kind of things, the role of high performance interconnect you see with respect to storage cluster, you also see that in the multi-tier data centers, and many times these kind of systems are also integrated over local area network and wide area network. So in that context, the role of high performance networking is very significant in designing these kinds of systems. So in this context, if you are an architect or if you're a designer, if you're an user of these systems, you may be trying to think how to build a balanced HPC system using high performance networks. You might have some questions saying what are the major bottlenecks in traditional computing systems? How are high performance networks were designed? What are their architectural features? How the communication stacks look like for high performance networks? What are the protocols leading to convergence? What are the different kinds of communication semantics, novel features, and network management for high performance networks? And how do you define the architecture and topology of also for some of these networks? And what kind of software libraries are available for these networks? And how these these libraries are going to help me? And also, you may also try to know like what kind of components, novel features, and products are available so that you can actually build and use these systems in your environment. So to answer all these questions, we have actually brought together this tutorial, which will really go into a lot of details of how these protocols have been designed historically and what is available now. And as you can see from this slide, we'll start with like the Ethernet, go through InfiniBand, all the different variations, even Omni-Path. And not only just at a high level, but we'll be able to go into some details of some of these protocols, what actions happens at the protocol layer, what happens at the adapter layer, what happens at the switch layers, etc. So the outline of the tutorial is like this. We'll be having a very high level introduction followed by some rationale of high performance networking. We'll be defining communication models, semantics for high performance networks, and then go down architecture overview of range of high performance networks available, like starting with InfiniBand, high speed Ethernet, their convergence, Omni-Path interconnect, NVLink, NVSwitch, Amazon EFA, and also Cray Slingshot, Fujitsu Tofu, Google Aquila. So you will get a very broad range of all these networks and their features. And then once we cover those things, we'll also be taking a look at the overview of the software stacks for especially focusing on the commodity high performance networks. We'll present some sample case studies, performance numbers. And to add all these things, we also have a set of nice hands-on exercises towards the end. You yourself will be able to actually use a remote cluster and again hands-on experience with the different features of the advanced networks. You'll be able to actually see and run, for example, like a InfiniBand benchmarks with latency, bandwidth, MPI level performance, and many more. I hope this tutorial will be of interest to you. If so, please feel free to join us. This will be held on 13th November, Sunday, in the room D163, 8:30 to 12 p.m. CST. And the more details are available at this link. And we look forward to seeing you at the tutorial. If you have any questions prior to this tutorial, please feel free to send me a note. My email address and Dr. Harish Rumani's email address are there, and we'll be very happy to answer those before the tutorial. Thank you.